everyone, welcome back to Spoon FPV. So I'm doing a build tutorial on how to set up kind of a more advanced racing quad, and as I was doing it I realized that I don't want my viewers to build their quad exactly the way that I did, because those are the parts that I used. I want to provide a guide on selecting the right parts for your quad. So if you're an advanced guy and you've built, hundreds of quads, I ask that you stick around and maybe post in the comments what you think that I missed, so that everybody can learn from this. But if you're new to the hobby, you should find this very useful. So one more time, you have your transmitter, which controls the quad. You have your goggles, which you use to see the quad. You have receivers on here, which receive the video from the quad. You have a receiver module on this guy, which talks, receiver module on this on your quad, which talks to the radio. You have a video transmitter on this, which talks to the goggles. You have a flight controller, which is used to fly the machine. You have a power distribution board, which is used to distribute power throughout the whole machine. You have a camera, which is what you use to see when you're flying it. You have electronic speed controllers, which are controlled by the flight controller, which control the speed of the motors which fly it. You have the motors on here, and you have all the different props that you can try for the motors. Alright, so let's start with the one that I think people spend the most time selecting, but I think makes the least amount of difference, which is the frame. So this is an X style, this is an extended X style frame, and it is a unibody. So X just means that the arms come out this way, and you'll hear some people say stretch X, and stretch X means that they've extended the X kind of this way. They've stretched it out a little bit, and then it's is a 5-inch frame. So there's this type, which is a solid base, and there's like this type, which is a removable arm style, and you can see that there's a lot more bolts on the removable arm style than this style. I like the solid bottom plate more, and I think manufacturers, a lot of people have been pushing this one, or this style, with removable arms. And the reason I'm showing a blackout is because it's an older style one, and this is the old way of doing it. And the reason why manufacturers like this one is because it's the cheapest to manufacture. So this costs more to manufacture than removable arms, because all of this carbon in here, all of this stuff, it has to be a lot bigger piece of carbon. With the removable arms, they can just stack them nice and neatly next to each other, and they get to use a lot more of the carbon fiber, and it's a lot less machining intensive to cut out. So I feel like manufacturers have been really pushing the removable arms like you're gonna break an arm, but really what most people break on the removable arm style is they break this plate, or half the time they break this. Sometimes they break arms, but solid base, generally don't break these. And then there's the other thing to look for is what size is it? Like, can I fit? What size prop can I fit on it? Is it a 5-inch? Is it a 6-inch? Is it a 8-inch? So 5-inch is usually going to be a 200, 190, 195, and that is this dimension, 190 from here to here, from motor to motor distance. Well, that doesn't really show it well, but that number is the motor to motor distance. And then you can see how thick the carbon is. So this is, I think it's a 4mm plate. So either 4mm, 3mm, how thick this is. I like a 4mm bottom plate for my basher quads, and 3mm for my race quads, because it's a little bit lighter. But acro doesn't really matter as much. And the other thing I'm looking for is how much space is there available. So this one provides a lot of interior space, but not as much as some frames. And the more interior space you have, the easier your build is going to be, and the more parts that you're going to be able to use with that frame. So back to this old school like blackout style, we have, you know, there's a ton of space inside of here to put parts and such. And then, you know, I have this guy, which is an X frame. This is an H frame, by the way. And the difference between H and X is just H. Let me zoom this out a little bit. Wrong way. Okay. So H just refers to how the arms come out. These kind of come out straight, right? You know, that's H. This is an X because they're in an X form. But if you look at them, the motors are in almost exactly the same place. So these two frames, aside from their weight difference, are going to fly almost identical. And anybody that tells you that, you know, this frame flies amazing compared to another one, if they're the same weight and they have the same motor configuration, they're pretty much going to fly exactly the same. So frames for me is like, oh, and then let me grab another one off the wall here. So this is a True X frame, and you can see that the motors are like equally spaced. They are, it's a True X. This is more of a Stretch X. But you can see in this one there's a lot less build space inside, and this is not what I would recommend for somebody that's their first build to build. I mean, these are a little bit faster because they're lighter, but they are the most challenging thing to build, because if you can see, there's like not everything is fit inside of this one. I had to put things on the outside, and I had to be very careful with the components that I selected. And this is actually kind of big for an X-ray. You know, this one, you can see how much cleaner it is. Everything fits inside, and it's nice and neat because there's more space, and then there's space for me to put stuff on top of it. So that's kind of what I look for when I'm looking at the frame. So let's talk about props. Alright, so propellers. We have, you know, there are numbers on the propellers. So this is a 5x4x3. What does that mean? It is a 5-inch diameter. The circle, the disc area is 5 inches. It has a 4-inch pitch. So 4 inches means that theoretically, for every 1 revolution of this, it's going to move 4 inches in this direction for every 1 revolution. So the higher the pitch number, the greater, the more aggressive this side is, and the more energy it's going to take to turn the propeller. And then the 3 is the number of blades it is. So this is a 5x4x3. So it's a 5-inch prop, 4-inch pitch, 3 inches, or 3 blades. This is a 2-bladed prop, so it's a 5x4.5. It is a, and it is what they call a bullnose style. So you have, this is the tip end. So this is bullnose, and what they've done is they cut them down. This is very inefficient end, but it makes a lot more power because you have a wider propeller section here. This is a, I don't know what this is. This is a 50/40x4. So, and this has a standard tip, which allows the air to not spill over and make noise. There are different materials. There's polycarb, there's durable, there's the glass fiber composite. So the stiffer the prop is, the more efficient it's going to be, but the easier it's going to be to break. And then you even have 6-bladed props. So this is a 50/40x6. And the number of blades, kind of like a good rule of thumb, is you want more blades is more accurate cornering. Less blades is more top speed. So this one, don't get a 6-blade here. I'm just going to take this out of the mix, but I just wanted to show you these don't. I don't know what these are good for. So now that that's out of the way, the 4 blades are really good for if you have tight courses with not many straightaways, because they really grab. They have a heavy disc area, and there's a lot of air grabbing. But what happens with the more blades is they start to they're less efficient, and they start to stall at higher speeds. So you get up to this this you'll rip through the first, the first little bit of it. The punch out is insane. The cornering is great, but then they get up to a speed and they just kind of like flatten off. They can't push anymore. They just kind of stop. So I think a lot of guys are flying these, and these are great for tighter courses. And they handle great. So, and then the 3 blades are kind of a general, like, all-around prop. And if you want just pure top-end speed, a 2-blade, not bullnose, because this is inefficient, is where it's at for pure top-end speed. So this is kind of a 3-blade is kind of a good mix of all the kinds, or all the different kinds, and it gives you good cornering, it gives you good top end. So that's why you'll see a lot of guys have like switched to 3 blades, and that's primarily what they fly. And I actually don't like to switch back and forth between 2, 3, and 4 based on tracks. And it's not because that it's not the right thing to do, but it's just because I don't have enough time and experience to fly multiple bladed props, and just I like to have a setup that I fly and just keep it very, very consistent. So, and then there's the material. So this is a really bendy material. This is the durable material. They make them out of polycarb, which is a lot stiffer, and it will break more easily, but it's it's a lot better for hard surfaces. And then they make the glass fiber composites. I think this is kind of an old school propeller. I don't think that that's really good for anything other than top end speed. So, and then whatever the racecraft's made out of. So for newer guys, I'd prefer durable props is where it's at, because you bend a prop, you just bend it right back. So that's kind of my prop selection guide. So I guess next is on to motors. Okay, so motors. There are tons of them out there, and they do make a difference. So there's a lot of tech that goes into motors. I'm just going to kind of basically hit on it really quickly. This is a 2205 2600 kV. What the heck does that mean, right? So 22, the first numbers in this, the 2205, the 22 refers to the motor diameter. So this, the diameter of the inner stator in this is 22 millimeters, and the 05 is the height of the stator. So it's 5 millimeters tall, and it is 22 millimeters in diameter. And the 2600 kV is how fast the motor spins. So the higher the number, the faster the motor is going to be, but the less torque that it's going to have. So 2600 kV, it's a higher top end, but it has less low end torque. And there's more to it than that. There's the type of the windings inside of this. They have a thin coating on them so that they don't short out against each other. So there's the thickness of the coating on the winding. There is the type of magnet that is used. The NM52 is a very powerful magnet, and that's what I generally look for when I look for motors. And then this one actually has, I don't know if you can see it in there. Come on, focus. Focus, don't focus on that. Okay, this one has arc magnets inside of it. So they actually, you can see how close see how the magnets kind of curve, and that allows them to get really, really tight up against that stator. And the magnetic force is actually proportional to the square of the distance. So the closer you can get the magnet to those windings, the more powerful your motor is going to be. And by curving the magnets, you can actually put them a lot closer. So I look for arc magnets, thin coating on the windings, and NM52 magnets, or like a powerful magnet. And Mini Quad Test Bench is like a good resource to go to look at the thrust curves on all of these and just data overload. But really, it's about the stator diameter. If you buy a modern motor, it's about the stator diameter and the kV. So for a 5-inch quad, a lot of guys run 2300 kV. I like 2600 kV with a less pitch prop, but that's kind of a personal preference thing. So, and then 4-inch, some guys are running the 1806s with 4000 kV on those. And those happen to be blazing setups, and some guys are still running 22 size motors on those. On a 5-inch, you should be running 2205 or 2206, maybe even 2207, but 2207 is more for a 6-inch quad. And then the kV should be somewhere between 2600 or between 2300 and 2600. And then for a 3-inch quad, it should be an 1806, 3600 to 4000 or higher kV for the 3-inch quads. So those are the numbers for the motors. So let's talk about ESCs. One more thing that I almost forgot about the motors is the weight of the motors. I look at how heavy they are. I think a good 2205 or 2206 motor should be around or under 30 grams. So, and the motors make a big difference on how much your quad weighs. So you save 5 grams a motor, that's like taking a whole motor off of the quad, if you're running 25 gram motors versus 30 gram motors. So it's, a lot of guys like the heavier motors, but I'm not a fan of them for that reason, because they add so much to the quad. So there you go. All right, let's talk about the ESCs now. All right, so ESC stands for Electronic Speed Controller. There are a couple numbers that are important with the ESC, and that is the amperage that it can support. This is a 30 amp, which is pretty good for a 5-inch setup. There are 20 amp ESCs, which is good for like a 4-inch setup. And then, between 10 and 12 amp ESCs is good for a 3-inch setup. The way the ESC works is you have the power come in, and then there are 3 phases that go out to the motor. It doesn't really matter which way you wire these. If you switch one of these, it will reverse the motor, but you can do all of that in software now. The thing that I look for in an ESC is the form factor, how small it is, how much that it weighs, and what the amperage is. So this was kind of state of the art a year and a half ago. This is a Simon K ESC. This is 20 amps. This is 30 amps, just to give you kind of a comparison of like where. So the stuff is evolving really quick, and there are 2 things So in addition to the amperage and the form factor and the weight, I want it to support D-Shot or have BL-HELI-S. So if you have a BL-HELI-S ESC, it's going to support D-Shot, and if you have a KISS ESC, it's going to support D-Shot as well. And the BL-HELI-S and KISS, like, they have, basically it's the best hardware available at the time, or at this time. So it's kind of going to future-proof yourself. So that's what I look for in my ESC selection. All right, next thing to talk about is PDB, and that stands for Power Distribution Board. That's where all of your ESCs are going to get wired into. So on this one, the ESCs get wired into this side over here, positive, negative, and then the main power comes into these, and it also has an OSD inside of it. So what I look for in my PDB is, and I like them to have an OSD in them if I'm not going to run a flight controller with an OSD, and I like them to support, the other thing is, like, they have to support the amount of current that you're going to pull through your setup. So if you're running 30 amp ESCs, and 4 of them, it's 4 times 30, so it should be able to support 120 amps. And not many do, but I guess for the most part the batteries don't put out at that level nowadays anyhow. And the other thing you want in them is voltage regulators. So this one has a 12 volt and a 5 volt regulator, and that provides clean power for both your video transmitter and your video transmitter and your camera and your flight controller. And clean power is so important to reducing noise. So a lot of guys, they'll use like, this is an LC filter. This is kind of a big one, but these have kind of, with a good PDB that has good linear regulators in it, you won't need one of these with modern equipment. So PDB stands for Power Distribution Board, and you're going to need a power distribution board or a flight controller with a power distribution board in it. And if I'm already putting it in, I like one that has an OSD in it. So that's kind of what I look for in my PDB. But the big things are the 12 volt and 5 volt output, and that it supports the current that you're going to need, and where the pads are located. So this one actually is, let me grab a new one. Alright, so this is a newer style one. Sorry, it took me a while to find that one. So the pads on this, the separate pads make it a lot easier to solder, and they're in the corners where your wires are going to go. So like the layout is actually kind of important, and the form factor is important. So 36 by 36, that is the standard size for everything, and that's going to fit inside of your quad. So if you're building a tighter quad, like some of them will be 36 by like 40, and they'll come like way out to here in one dimension, and so they'll be like this wide on one side of them, and then they won't fit in a lot of frames. So 36 by 36 is important. Where the pads go, the 5 volt and the 12 volt power supply, and the current rating on that 5 volt and 12 volt supply. So depending on what you're going to run, if you're going to run your VTX off of 5 volts, or you're going to run something heavy off of 5 volts, you need one that does 2 or 3 amps. If you're not going to do that, then if you're going to run that straight off of the raw input power, then you don't need a really heavy current rating on those. So that's what I look for in a power distribution board. Now let's talk about flight controllers. So if you watch my channel, you'll know that I really like this flight controller. It is the Betaflight F3 flight controller, because it basically combines all the features we just talked about in the PDB, OSD, and it puts them inside of a flight controller. But this isn't the end-all be-all in flight controllers. There are still others out there that are good. So ones that you'll see, this is a KK2. This is great for flying planes, and if you want to like fool around and stuff. But it's not good for your multi-rotor at this point, because it's not going to be very fast. So and if you look at the size, it's not the 36 by 36 that we talked about earlier. So we kind of want something smaller. So I'll put this one aside. As far as tunability on something like, I mean, this thing, I can tune one of these in 10 minutes, but that's because it's very simple and not doing very much. Okay, anyway. All right, so the other things you want to look at is it an F1 or an F3 or F4 processor? So what's the difference? This is an ACE32. I'm sure if you're new to this, and you look up flight controllers, this is the one that pops up first on the internet, because it made the biggest waves, and it changed things for the hobby, and it was freaking amazing. And I mean, this is the grandfather to the modern flight controller, and we owe the guys over the Clean Flight and everybody a big thanks for this one. But it's an F1, and there are better options in the same price range that are F3 now. So this is kind of an old, outdated board, because it only has 2 UARTs on it, and I think Project Blue Falcon has a good video on why not to buy the NAs. But basically, there are better options. So thanks, but thanks for getting me into the hobby. But now there's better things. All right, so thank you, Hydra, for the Clean Flight controller. So what I look for in a flight controller now is that it's either an F3 or F4 board, and what gyro it has on it, and whether or not it needs a 5 volt source. So some of them need an external 5 volt source. Some of them use gyros like the MPU 6050, which are only an I2C interface. So this is the actual gyro on this board, and this is the flight controller chip. This is an F3 chip, and then this is an MPU 6000 gyro, which uses an SPI interface. And then these two can communicate over that interface, the SPI interface, which can support the 32K talk, but the gyro itself can only operates at 8K. So this flight controller will only do 8K, but F3 boards are limited to 8K clock cycle time. Oh boy, this is getting really technical, and I do not want to get technical. All right, so let's try and less technical it. So I look for what interface it is. If it's I2C, that immediately rules it out for me, because I know that it's not going to support the faster protocol. If it's an F3 board, and it's and basically whoever's selling these needs to put on their site what cycle times they support, rather than you having to go and look through the community and see if it's SPI or I2C or what gyro it is. But look at the gyro that's on it, and then the interface that gyro goes. If it's I2C, it's going to be slower. If it's SPI, it's going to be faster. There are certain ones I'll put details in the description, but the MPU 6000 is a really good gyro because it supports 8K over SPI, and if you're going to go F3, it can support 8K, and the newer versions can support up to 32K, but you need a different gyro than the 6000. You need a 9000 or the 2032. There's several different gyros that can support that, but it needs to be an SPI interface, and all of these will support clean flight, beta flight, race flight. You can flash all of these different boards to those different configurators, but the F3 chip is a good chip for beta flight. The F4 chip is kind of required for race flight, and you need a well, you don't need, it will still run on an F3 chip, but you should have a gyro that supports the 32K interface if you're really going to get the full advantage out of race flight and the new versions of beta flight. But really, I don't notice a difference from 32K and 8K. Alright, so flight controller, I'm looking for, does it require an external 5-volt input? Does it support a 3.3 volt output if you fly Spectrum, or does it support a 5-volt output if you fly FreeSky? And we'll talk about receivers a little bit later. Which gyro is on it and what the interface is. So the gyro, some gyros can support up to 32K, some gyros can support up to 8K. The MPU 6000 is an 8K over SPI. The MPU 6050 is a 4K over I2C. So the interface, this is the chip, this is the gyro. The interface between the two of them is what determines the speed up to a point, and then the gyro determines the speed when you start talking faster and faster loop times. So, MPU 6000 is good if you want to run an 8K gyro, and then there are other gyros if you want to run 32K loop times, but you need an F4 flight controller for that. Hopefully that is simple enough for everybody to follow. But all of these boards, you can flash clean flight, beta flight, navi flight, race flight on them. But race flight, you're probably going to want an F4 chip, and beta flight is getting to the point where you're going to want an F4 chip as well, to fully flesh out all the features. But I don't notice a difference between the 32K and 8K. I think 8K is kind of a good stopping point, because from going from 2K to 4K, which is the loop time, and I have a video on that, I'll link it in the corner here. Going from one to the other, 2K to 4K, I noticed a big difference going from 4K to 8K. It was a much smaller difference, and going from 8K to 32K, yeah, there's some difference, but it is like so minute. I don't think that it's, at this point, that the hardware, like all the hardware doesn't support it, and I don't think that it's worth the trouble for me to switch all my gear at this point. So, because I don't think that it's that much better. So there you have it. Those are flight controllers. Alright, so now that the flight controllers are out of the way, let's talk about how we communicate to the flight controller. So the flight controller is communicated with a receiver. So the receiver talks to our radio, which talks to the flight controller. So these are two different styles of receiver. This is the protocol at which it talks to it over is what the input and what the voltage is. So this one is a 5 volt, but it communicates over a PWM, which is kind of the old way to do it, which is a much slower, older. So I would not recommend PWM because it requires a lot of wires. You have to run a wire from every single one of these pins to the flight controller for your 4 channels, and if you're going to run 6 channels, you have to run even more. So I would not recommend a PWM. And then there is, some of these do PPM, which sends it over a single, like this has a bind DAT port. I'm not sure that this one does PPM over the DAT, but if it does do PPM over the DAT, you can actually run one set over, but PPM, or sometimes it's referred to as combined CPPM, which is combined PPM, is a one-wire interface, and it was the original interface, but it is still slower. It is a much longer packet than the S-Bus or serial interfaces that take less time. So it's all about reducing the amount of time that it takes for your receiver to get the signals. So as far as serial interface radios go, you have, you know, the two main competitors are the Spectrum and Free Sky, and it depends on what radio you have. If you have a Spectrum radio, you can use Spectrum. If you have a Free Sky radio, you can use Free Sky. The Turnigy Evolution also uses, I don't have those to show you, but that also uses a serial interface. But really the two things you need to look for in the receiver are, or three things I guess, are the size that it is, whether it's going to fit in your quadcopter, what voltage it runs on, and if it has a serial output. So serial output is important, size is important, and then what voltage it runs on. Spectrum runs on 3.3, Free Sky runs on 5. So there you go. Alright, the next thing to do is your camera. So there are different styles of camera. This is a board camera. They have different sensors on them. You know, the number of pixels. So depending on where you are in the world, you want if you're an NTSC nation like we are here in America, you want an NTSC camera. And if you're a PAL nation, you want a PAL camera. Now PAL technically is better, and if you're a really technical guy, you probably want to fly PAL because you get more lines. But if honestly, like, if whatever your country supports, that's the one you should stick with, because like you're gonna have the least amount of headaches. So, but that's just my 2 cents. Anyway, so there's a board camera. The things that I look at when I look at the cameras is what voltage input that they support, and well, what voltage range and their form factor. So this is the board camera, and then this is kind of a board camera that's been put in a case. And these are kind of older models. Most frames nowadays are going to be designed to support an HS. I'm sure you've heard the term HS1177 or HS1177 style. There are multiples out there that do that. This one just is a Runcam Swift. It is an HS1177 style. It's slightly narrower in this dimension than the HS1177, but and then there is the HS1190, which is now done by Foxier. The other thing I look for on these is, because like basically there's no point talking about the other cameras for frames, because most things are designed for this style camera anyhow. So there are mounting options on the side, and then there's different mounting options for everything has a mounting option for this in your frame nowadays, and what camera lens you want. So there's different numbers for the lenses. You have it is the focal length, so that you have a 3.1, which is going to be more of a, the longer the number, the more of a tunnel it's going to be. So you can have 4.8, which is going to, or 4 point something, whatever, 5 point something. You can even get 12s if you really want it to, but they're going to be more and more of a tunnel and more of a narrow field. Most guys are going to smaller numbers, which is a shorter field, distance here for the focal length, which provides a wider field of view. So 2.1, some guys even 1.8. The smaller the number, the wider the field of view, but also you get more and more fisheye as you start getting smaller and smaller. I like a 2.1, a lot of guys like a 2.5, and there's 2.8, which is also a pretty wide standard field of view. The others like 3.1, 3 maybe for planes, but definitely not for your mini quad, because it's just not wide enough. But I prefer 2.1, and then the other thing I look for is what voltage it supports on the input side, and if it's a top connector or bottom connector. I like a top connector because a lot of times you're tilting the camera. Can't see that. So here's one in a quad. I'm tilting the camera back, and you can see if it was a bottom connector, the bottom connector would be kind of pressed into the frame, but a top connector allows me a little bit more space to be off of the parts. So top connector is very important, what voltage, and some of them have an OSD built into them, which can kind of make your build a little bit simpler. The The Runcam Swift 2 has an OSD built into it. The Foxeer Arrow has an OSD built into it, but that is not a good so Foxeer came out with the 1190 because that one was not very good, but the new Foxeer 1190 is an OSD capable one that's like they support a wide input voltage range, like up to 35 volts. So the Foxeer Arrow and the Runcam Swift 2 have OSD built into them, and they support wide voltage input ranges, and they provide live voltage feed output or voltage on the screen, so that you're not killing your battery. But okay, let's talk about batteries, I guess. All right, so batteries. Oh man, I could do 2 hours talking about batteries, but you have 3S, 4S, 5S, 6S. What does that mean? That's the number of cells that there are. This one you can't really see it, and you probably can't see it in this. Well, you can kind of. There's 1, 2, 3, 4 cells in this. That's a 4S battery, which means that it is nominally 14.8 volts for 4S. The other numbers are the discharge, which is the C rating of the battery. So what that means is what that means is actually jack. It doesn't mean anything now because everybody lies about their C rating on them. But, well, not everybody. The Lumineer is actually pretty honest about their C rating. These are actually pretty decent batteries. They do deliver almost 80 C. But what that is you take this number, the 1300 milliamps, and you multiply that times the C rating, and that's what you should be able to pull out of them continuously without the battery failing. For the most part, manufacturers lie about it, and I feel that they should be sued and have to buy your batteries back. But that's whatever. It's common across the board. And people look at the C rating and think higher is better. Go with a good name brand on your battery, and price does not always dictate whether or not the battery's good enough. So the 1300, that number is like what capacity is inside of it. So that means that you can pull 1300 milliamp hours out of this one, it's basically like how much energy is in the battery. So you can pull 1300 milliamp hours out of this one before you destroy it. But they are, you don't want to take them down below 20%. So I generally stop at 900 on these, so that I'm not, because if you over discharge a lithium battery, you hurt it, and it won't have the same punch next time. And there's storage and all sorts of other considerations with it. But basically, you want to look at the size and the C rating and how much does it weigh, and what's the voltage. So there are 4-cell, 5-cell, 6-cell. Generally, if you're new to quadcopters, I'd recommend that you stay in the 3 or 4-cell range. Actually, you're going to be flying 4-cell relatively quickly, so get 4-cell and just limit your top end throttle and be easier on the sticks. But anyway, I would recommend 4-cell for newbies and people that are experienced, because that's generally what you're going to fly racing. And then there's things like graphene and non-graphene batteries, and what that is. The graphene batteries have generally they have a lot lower internal resistance, which it means is a measure of the sag that you're going to get on the battery, and they tend to last longer. And then you have high volts, which you're charging the battery. And so this one is nominally, you can charge it to 4.2 volts a cell. The high volts you can charge to 4.3, 4.35 of a cell, and they are better for the first 20 or 30 cycles. But I have not been able to find a high volt battery that really lasts as long as a regular battery. So I fly generally regular batteries, unless, but if you need a special charger for high volt batteries that can support high volts. So those are kind of the considerations when getting a battery, is what the C rating is, what the capacity is. For a 5-inch quad, I'm generally flying a 1300 or a 1500 or a 1550. For 4-inch, it's like it's around 1000 that I use, and then for 3-inch, 850, 800 to 1000 milliamp hours. And then do your research, and there's a lot of hype around batteries, but really what you want to look for is somebody that's tested the batteries and tested the current rating and actually saw if it meets the C rating, because a lot of batteries fall very short of their C rating. And I'm showing you a Lumineer because this battery does not fall short of its C rating. This battery delivers, and I've been very happy with these batteries. And then there are some other batteries that I've been happy with too, which are the Strix batteries, and I don't want to get into brands and everything, but and tell you what to pick. But basically on batteries, I can tell you that I'll tell you the ones that I've tried that are good and deliver what's or close to what's written on them, and that's the Lumineer, the Strix, the the Reeve electric batteries, and the True Spec batteries. Deliver what they say they're going to deliver, and they're not a bunch of hype. And there are some reviewers out there that have reviewed batteries and tested them scientifically, and go check those guys out, because that's how I selected my batteries. So now that we've talked about batteries, and I could talk about batteries all day. I love batteries. Let's talk about video transmitters. All right, so what I look for in a VTX, I kind of deep dive into that, and in another video I'll link it in here. But what I look for is multiple power outputs, and what voltage it supports, and does it do 40 channels, and that's pretty much it. And what size it is, so it's got to be relatively small. So, and the nice thing about like the new transmitters nowadays is they have these UFL connectors, and you can buy like these spare antenna connectors for them, so that if you break this, but basically you want a small one that supports, and look at what voltage is going into it, either 5 volts or does it support up to 6S. This one supports up to 4S direct input. Other than that, you need a voltage regulator, and then the TBS, like they have the HVs, and there's, just check my other video out. I kind of go over this in detail, but basically, there's 2 to look at nowadays, which is the Tramp and the TBS Unify. Alright, so your VTX is going to plug into an antenna that transmits. Now, there are 3 different types of antennas. For the transmitting, you have a linear antenna, and you have a right-hand polarized circular, and you have a left-hand polarized circular. Basically, what you need to know about linear is don't use them if you're flying with friends, and they generally, if you have one antenna facing this way and you have another one facing this way, which is very common for like flying FPV and acro, they don't receive very well. Like this is near zero signal received, and circular don't fly these. There, that's the end. Okay, done with linear. Circular polarization, what you need to know is you have right-hand circular polarization and left-hand circular polarization. And the right hand, if you're running right hand on the transmit side, which is the VTX, which goes in your quad, you need to run right hand on the receive side, which is what goes in your goggles. And we'll talk about your goggles and receiving in a little bit. But basically, there are multiple different types. I look at the size. You can see these are a little bit bigger, and then what the durability is. So on my quads, I kind of like a smaller one. These are better for wings and stuff. The bigger ones, but they're a little more fragile. The DuraSpec actually is not that fragile, but it's a little heavy for a mini quad for my taste, based on like what else is out there now. But I don't want to be brand specific, and so basically I look at the size of it and whether it's right hand or left hand circular polarized, and then you have this is the Axie one, and I fly them and I find what I like. So if you're so you want a circular polarized on your transmit side, and the gain on the antenna is, there's like a big lobe around most of the circular polarized antennas, and it has a weak spot in the top and a weak spot in the bottom, but they basically transmit very evenly in all directions around them. And and then you have a patch antenna. This is not, for 99.9% of people, this is not for transmitting. So this is for receiving video if on the receive side. So let's talk about the receiver. So these are different receiver modules that go inside of goggles, and you can get receivers that go on a base station. But now base stations for me are kind of only for like super long range stuff, because the receivers with diversity, like this one is what I'm using in my goggles. I actually have, I have two antennas on here. So, you know, one side receives my signal. Do I have? So one side I will use for receiving signal all around. Like this antenna receives signal all around. It's a right-hand circular polarized. And then I will point another antenna, like a patch antenna or a helical or whatever, in the direction where like I anticipate doing most of my flying. So this one will, the circular polarized that's like good in all directions, will catch me when I fly behind myself or fly outside of the cone that's like this patch has. And then this one will catch me when I fly outside of the cone, but this one will have the strongest receive signal when it's inside of that patch, and will let me fly the farthest. So the receiver itself that goes inside of this is a diversity receiver. It has two inputs. They make modules like this that have, you know, there'll be diversity on one side, so diversity, and you can get, we'll talk about goggles in a minute, but basically I'm looking for, does it work with my set of goggles, and does it work with my set of goggles, and does it support 40 channels? So let's talk about the goggles now. So there are different types of goggles that you're going to need for your FPV setup, and this is a head unit. It has the two different diopters for your eyes, and this is what I like, this style, and then they have a box style as well. And some guys fly with just a television screen in front of them, and you know, I'm not a big fan of I like having the television screen with me to hand to people, but I'm not a fan of it for, oh, let me grab it here. So they'll fly with a screen style, and you know, this is great to hand to people, or you know, collect DVR, like just show somebody what you're doing. But I'm not a fan of flying through these because it's not as immersive as the head box style or the over the eye style. This is by far the most popular style, and with some of these have a built-in VTX, or sorry, not a built-in receiver. And some of them you need to buy receiver modules for. This version I have to buy the receiver module for, but I like the ones that you buy different receiver modules for, because it gives you the option to get, you know, to have it gives you the widest range of, you know, options when you're looking for things. So oh yeah, the other thing is just the radio. So let's talk about radio. Alright, so what do I look for when I look at a radio? So your radio is going to be specific to, it's only going to talk to certain receivers. It's only going to talk to the receivers that are of its kind, unless it supports a module bay in the back. So a lot of radios have a module in the bay, a module bay that you can put different modules in, and these are a standard, like developed by JR. And you know, if it has a module bay, you basically can talk to anything, and you know, a lot of them have a trainer port that you can output through the trainer port on. The other thing I'm looking at is it must be at least 5 channels, and it must have decent gimbals or the ability to upgrade gimbals. So I can talk about the different radios. This is there are so many of them out there, but here, let's talk about the receiver modules available for the main ones. So this is the receiver module for Spectrum, that does the serial protocol. That's the smallest one you can do. This is the smallest one that does, well, this is the smallest one for FreeSky that does serial protocol. And then the Turnigy Evolution has one that's about this size that does serial protocol. So I honestly choose my radio based on what receivers are available for, because it's only going to talk to the certain kind. And then the other thing is with using the modules on the back is you're adding delay with this. So there's actually like a communication to the module that would normally go straight out the radio. That takes a little bit of extra time, and you're adding delay in your signal. So you want to minimize the delay. So you really want to use the radio that uses the receiver that you like. Now, this is basically you know, there's three main players: the Spectrum, the Free Sky, the Turnigy Evolution, and I really couldn't point you to which one is right for you. That's something you're gonna have to decide. But there are some things to look at. Is, you know, does it have 5 channels? Are the receivers small that support serial protocol? And, you know, how you know, is it going to fit in my backpack? I mean, because this one is, you know, a little big for that. Does it have a bay? Does it have a replaceable battery? There's a lot of things to look at when you look at radios, but, you know, there are the main 3. Anyway, that's it for transmitters. All right, so those are the parts that I use for my FPV builds, and, you know, I hope that you found this informative and you hit that subscribe button that I'll put here, and maybe click on some of my other videos there. And, you know, if you think that I missed something, please leave it in the comments. And if you have any questions, you know, ask me, because I'm relatively responsive. I do read everybody's comments. So, and, you know, don't forget, you could probably eat soup with a fork, but sometimes you just need a spoon. I hope you enjoy this as much as I do.